Hello guys, so I would like us to look at how to go about this question. Expand exponential sine x up to the term in x raised to power 4 using Maclaurin's series, hence integrate that. Okay, so Maclaurin's series, let's come on to the solution. We can express a function f of x as f of 0 plus x f prime of 0 plus x squared over 2 factorial f double prime of 0 plus x cubed over 3 factorial f third prime of 0 plus x raised to power 4 over 4 factorial f fourth prime of 0. So we'll go all the way up to the term x raised to power 4. Now our f of x is exponential sine x. So what is our f of 0? Exponential sine of 0. Sine of 0 is 0, so exponential 0 will give us 1. Then we go on to evaluate f prime of x. So we differentiate this function. Now we're going to use the chain rule. So first of all, differentiate the exponential. Differentiating the exponential, we'll just get exponential sine x, and then multiply by the derivative of like what is inside the bracket, that is sine x. The derivative of sine x is cos x. So this will be our f prime of x. And this is like the short form when you're using chain rule. However, we could just use the long form, like let's call this y. Y is equal to exponential sine x, and then let this be u. So we know that if we want to get dy dx when we've, so let u be equal to sine x. Dy dx will be given by dy du dx. What is dy du? Now, this is y is equal to, let me write it, y is equal to exponential u. So dy du will be exponential u multiplied by du dx, differentiating u with respect to x, that will give us cos x. So this is simply exponential u, and our u is sine x cos x. So up here, we just use the shortcut, but if you want to go on the long way using chain rule, this is how you go about it. You still get the same answer. So what is our f prime of 0? So replace where there's x with 0. We will have this as exponential 0, cos of 0. Cos of 0 is 1, exponential 0 is 1, so this gives 1. Okay, moving on swiftly, we want to evaluate f double prime of x. So we will use the product rule. We have two functions here, so let this one be u and let this one be v. So we will be evaluating u prime v plus v prime u. Now, if this is u, differentiating exponential sine x, that's what we just did here. We will get exponential sine x cos x multiplied by cos x plus, now differentiating cos x, the derivative of cos x is minus sine x. Multiply this with exponential sine x. So this is our f double prime of x. So what is our f double prime of 0? Replacing with 0 where there is x, we will have, so this will give us 0, 1, 0, 1. So we have 1, 0, 1. So we have 1 here. And then because of sign here, sign of 0 is 0. So this just gives us 1. Then let me write this nicely. The f double prime of x, we will have it as exponential sine x cos squared x minus sine x exponential sine x. And now we want to evaluate f third prime of x. So the third derivative of this. So here, I can write this because there's exponential x and exponential x here. I can have this as exponential sine x into cos squared x minus sine x. Then let this be u and let this be v. So u prime v, u prime, the derivative of this, we already know it's exponential sine x cos x multiplied with v, which is cos squared x minus sine x, plus v prime u. So v, differentiating this, so derivative of cos squared x will be 2 cos x into minus sine x, i.e. what I've done for cos squared is just have cos squared x is the same as cos x squared. So differentiating this is 2 into cos x raised to power minus 1 multiplied by the derivative of what is inside, which is minus sine x. So that's how I've done it. So that's the derivative of this multiplied by exponential sine x. So what is our f third prime of 0? Replacing with 0 where there's x. So 0, 0, that will give us 1. 0, this will give us 1. 1 minus 0 will give 1. So this gives 1 on this end. And then replacing with 0 here, we will just have 0 because sine of 0 is 0. So the whole of this will give us 0. So eventually that gives us 1. Now, finally, let's get the fourth derivative. So I want to rewrite the function nicely, simply, so that you can be able to see it clearly. So the third derivative here is let's say, so we have this, try and see if we have any common terms that we can factor out to make our work easy. So here we have exponential sine x, here we have cos x, and here we have, so we can be able to factor out exponential sine x cos x. Then what does that leave us with? So we have cos squared x minus sine x plus, we've factored out this, and this actually it's minus 2 sine x. So minus 2 sine x and minus sine x, you can combine that. So this will give us exponential sine x cos x into cos squared x minus 3 sine x. So this is our third prime. We want to get the fourth derivative. So what is our f fourth prime of x? Now let the whole of this be u, and then let this be v. So what is the derivative of exponential sine x cos x? Now we use product rule. So using product rule very fast, differentiate this will give us exponential sine x cos x multiplied with cos x plus differentiating cos x, we have minus sine x multiplied with exponential sine x. All this is just u prime. So u prime multiplied with v, and our v is cos squared x minus 3 sine x plus v prime. So differentiating this, differentiating cos squared x, first of all, we'll have 2 cos x into minus sine x. And then differentiating minus 3 sine x, we'll have minus 3 cos x. So the whole of this is v prime multiplied by u. And our u, I'll just write it here, exponential sine x cos x. So what is our f fourth prime of 0? Where there's x, we replace with 0. So 0, replacing 0, 0 there, we'll have 1. Replacing 0, we'll have 0 there. Now we still have this replacing 0 here, we'll have 1. 1 minus 0, we'll have 1. So 1 multiplied by the whole of this will still give 1. Okay, replacing 0, 0 here will give us 1. Replacing 0 here will give us 0 for the whole of this part. So we remain with this part. If we replace 0 here, we will have 1. So this will give us minus 3. Minus 3 multiplied with this, we'll have minus 3 eventually. So this will give us minus 2. So now we come and replace our values. Okay, so up to where we've reached so far, I feel like there's an error, so I want us to go back and identify the error. Okay, so right here where we were looking at the third prime, I want us to go over it again. Now, this is what we had for our second derivative. So differentiating this, the derivative of exponential sine x is exponential sine x cos x multiplied with the derivative of this, and the derivative, sorry, multiplied with this. So this is u prime v plus v prime. Differentiating this, we have 2, the whole of this, 2 cos x into minus sin x, and then we didn't differentiate this part here. That's where the problem is coming in. So differentiating that last bit there, the derivative of this, let me write it here, cos squared x minus sin x. Just differentiating this alone, we say that you can write that as cos x squared. So this will be 2 cos x raised to power 1, and then multiply the derivative of what is inside, which is minus sin x. And then differentiating minus sin x. So that will give us minus cos x. So that's the whole derivative of this. So 2 cos x minus sin x, and then we have minus cos x, which we had not included. So v prime u. And what is our u? Exponential sine x. So in this case, what is our f third prime of 0? Let's replace 0, 0, that gives us 1. 0 gives us 1 again, 1 minus 0. So we have 1 there. Replacing on this side, exponential sine x will give us 1 out here. Then because of this sign, if you put 0 here, the whole of this will give 0. So putting 0 here, we will have 1. So negative 1 multiplied by 1. So this gives us negative 1. So eventually the f third prime will give us a 0. Will give us a 0. Okay, so now let's go on to the fourth prime and see what we get. So evaluating the fourth prime, f fourth prime of x, allow me to first of all simplify it. So let's see if it has anything in common. What's here in common? I have exponential x and cos x on both sides. So I can write this as exponential sine x cos x. If I factor that out, what do I remain with? I have cos squared x minus sine x, and then on this other end, I have a minus, because I've factored out the cos. I've factored out the cos x. So I remain here with minus 2 sine x, and then minus 1. Okay, this is 1. So if you remove cos x from here, here you'll remain with minus 2 sine x, and here you'll remain with minus 1. So that's what I have, which I can further simplify. I can write this as exponential sine x cos x. So exponential sine x cos x, and then this is cos squared x sine x, this gives me minus 3 sine x minus 1. Okay, so now let's differentiate this. So this is our f third prime of x. So what's our f fourth prime of x? So differentiating this, let's call the whole of this u, and let's call this v. Then you want u prime v plus v prime u. So u prime, if we come differentiate this, we will use product rule. So I'll first of all start by differentiating this. I'll get exponential sine x cos x multiplied with cos x, plus I differentiate cos x, now I get minus sine x multiplied with exponential sine x. Now this is just u prime, the whole of this is u prime multiplied with v, which is cos squared x minus 3 sine x minus 1, plus v prime. So differentiating this, we're going to have 2 cos x into minus sine x minus 3 cos x, differentiating 1 will get 0. So this is v prime multiplied with u. U is exponential sine x cos x. So what is our f fourth prime of 0? Let's replace with 0. Replacing 0, 0 here will get 1. Replacing 0 here where the sign, the whole of this will be 0. The whole of this will be 1. So we'll have minus 3 here, but let's start from here. So replacing 0, 0 here, 1, 1. Replacing 0 here, we'll have 0. So 1 plus 0, we have 1. And then replacing So let's write that down. We have 1 here. Then replacing 0 here, we have 1. Replacing 0 here, we have 0. And then 1. So 1 minus 1. 1 minus 1. Replacing 0 here, we have 0. 1. 1 minus 1 will give us 0. Okay, plus finally, replacing 0 here, we have 0. 0 minus 3 will give minus 3. So we have minus 3 there. And then replacing 0 here, we have 1. So eventually this gives us minus 3. Okay, fine. So the question wanted us to expand exponential sin x up to the term x4 using Maclaurin series, hence integrate. So now we have our f1 is 1, our f prime of 0, 1, f double prime of 0, 1, 0. So coming to write the expansion for exponential sine x, f0, our f0, we got it as 1 plus x, f prime of 0, plus x squared over 2 factorial f double prime of 0. So we also got this as 1. For x cubed, we got x cubed as 0, and we also got the 4th prime as 0. Okay, so plus x cubed over 3 factorial f prime of 0, we got it, f prime of 3, we got it to be 0 plus x raised to power 4 over 4 factorial, and the f fourth prime of 0, we got it to be negative 3. So the Maclaurin series expansion, if we are to simplify this, this is 1 plus x squared over 2 factorial. This gives 0, and then this last bit is minus 3 x raised to power 4 over 4 factorial. Now, the question wanted us to evaluate the integral from 0 to 1 of exponential sine x. So evaluating the integral from 0 to 1 of exponential sine x dx, this is the same as evaluating the integral from 0 to 1 of this here. So x squared over 2 factorial minus 3x raised to power 4 over 4 factorial dx. So integrating this simply gives x plus x squared over 2 plus x cubed over 3. And don't forget we have 2 factorial here, minus 3x raised to power 5 over 5 multiplied by 4 factorial. Integral is from 0 to 1. Then you can replace your values of 1 and then replace 0. So replacing 1, we have 1 plus 1 over 2 plus 1 over 3 into 2 factorial minus 3, replacing 1 here, we have 1 over 5 into 4 factorial. All this minus 0. If you replace 0, 0, 0, 0 here, and if you evaluate that, you get your answer. So that's how we go about that question.